Hello everyone and welcome back to Python Full Course Part 17, and today we're going to look at Matplotlib, which is a Python plotting library. So let's get started. First, you need to make sure that you have Matplotlib installed. So if you have a conda environment, all you need to do is that you just need to say conda install Matplotlib and you run it. And if you have pip, you don't have conda, then you can just do pip install matplotlib. If you want to verify that matplotlib works, then all you need to do is just open a Python shell in the terminal, and then you just say import matplotlib, and you can just say matplotlib dot underscore underscore version. And now I'm on version 3.3.2. So now you can quit. And now what I'm going to do is that I'm just going to create a new file, and I already created a file and it's called main.py, and as you can see I've already pre-filled with what we're going to learn today. So first, you want to make sure that you import matplotlib.pyplot as plt, and plt is just the main object we're going to use to do all kind of plotting stuff. So as we can see, we're just first going to put a title to our plot and then we'll display it. So I can just say plt.title and awesome title, and now I can show it. And to show it, you have to invoke the show command. So plt.show. Now all you need to do is just run this code. So you just open up another terminal and now you run it. So make sure that you have your environment, and then you can just run it with python main.py. And as you can see, this opens up a plot for me, so an awesome title with the axis here from 0 to 1 and 0 to 1. To close it, you just simply close it, and that's it. So we've seen how to add a title, but that's pretty boring. Now we want to add some lines. So Matplotlib was created so that you could use it at the same time with Numpy arrays. So if you import Numpy as np and you create arrays with Numpy, this is what Matplotlib likes to accept. He wants Numpy array. However, if you don't do Numpy arrays, it will also work. It's just that Numpy arrays are very convenient for us. So plt.plot, and let's say here we have to put the list of x coordinates, and here we have to put the list of y coordinates. So let's say I have a line that I'm going to define from 0, 1, 2, 3. And then here I just put the value, so let's just say it's 1, 2, 3, 4. So it would just go up. I just plot this, and then I put the show command later. Now I run it again, python main.py, and now you see I have an awesome title with the beautiful plot. So with list, it works. I just want to make it show you that it also works using Numpy arrays. So let's say I had x is equal to np.arange, and then let's say I do from 0 to 10 to 1. So just 0 to 10. And this is going to generate numbers between 0 up till 10. So I can just print x, and then let's just comment those out, and let's run it. Now you see that it prints what we want from 0 to 9 actually. I'm just going to say that y is just x times 2 plus 3, and this is the beauty of NumPy. It's just so simple to modify a NumPy array and to create a new NumPy array from it. So now I just say plt.plot, I say plt.plot x, y, and now you'll see that it will work. So again, make sure that you run your plt.show, and then we're up and running. So 0, it's up till somewhere here, I don't know what it is. And if you hover it, you'll see that it says it's around 3. So look at this pop-up here. It's a bit small, but trust me, it's written 0, 3. And 2, I guess it's somewhere around 8. I don't really care. But basically, 2 times 2 plus 3 is 7. So it should be around 7. So now we're just going to plot multiple lines. So let's say I said y2 is equal to x plus 3. So just x plus 3. And now I can say plt.plot x y2. Let's run it. And now we see we have two different lines. So a blue and an orange one. But we don't know what represents what. So how can we distinguish them? If you do it for enough time, you'll see that the blue one is always the first one and the orange is always the second one. But that's a bit confusing to first-time learners. So what you can do is that you can put a label. So I can say that this label is equal to first line. And then here I can say label is equal to second line. This will not change anything. So as you can see, nothing is going to change. But now that we have defined a label, we can create a legend. So if you create a legend, you just need to say plt.legend. Now when you run it, you'll see that you have the little square here that says a legend. So it says that the blue is the first line and orange is the second line. So this is what I use the most, a legend with two lines. So for example, when I want to train a Keras model and I want to see the loss as well as the validation loss, I'm just going to plot them next to each other and put the legend here says loss and then validation loss. And I can see if the validation loss is the same as the loss, or is it underfitting or overfitting and all that. So let's say I had that beautiful plot and now I want to save it to an image. All I need to do is that I just need to run plt.savefig, and now I can just put the name of the file. So I'll just name it image.png. Let's run it again, python main.py, and now close it, and I should have a new file. So I'm just going to look at my file explorer and see, oh, I have a blank file. So I know what's the error, and the error is that each time you run plt.show, it's going to clear up the canvas. So I have to save the figure before I show it. So just move the plt.show later on here, and now I can run it again, and now you see that I see it, all this, and now if I close it, that's okay, and now if I look here, you see that I have this beautiful image that's saved in my file explorer, so Ranger. It's actually pretty cool terminal applications. I maybe would make videos about my terminal setup if you guys like it. So let's just continue on. So we've seen how to save a plot, how to add a legend, how to plot lines, as well as how to add Untitled. And this is actually what I'm just going to use pretty much in my day-to-day work when I'm learning, but we're going to look at histograms. So let's say I had a standard distribution and I want to plot a histogram of it. So let's say I take, I don't know, 1,000 samples from it. So I'm just going to say random, so random array is equal to np.random.pend, and now I'm going to generate, let's say 2,000 numbers from the standard distribution. Now all I need to do is I just need to run plt.hist rand_n array, and I can put a title, so plt.title histogram of standard distribution, and now I can just run plt.show. Let's run it. Okay, this can ignore it, and now we have a beautiful histogram of the standard distribution. But is this pretty boring because the rectangles are so thick? I want to see more precisely, so I want to have more bins, and you can control this by using the keyword argument bins. So plt.hist your random array, and then you just say bins equal 100. Now if you run it, you'll see it's going to be much more precise. So now you see the histogram is much more precise and the bars are much more smaller. So this is very useful, for example, if you're doing a natural language processing task and then you want to know what is the distribution of sentence length or document lengths. So you can choose where should you truncate the document to have the most representative length. So histogram of standard distribution. Now we're up to bar charts. And bar charts are something that I rarely use, so let's look at the documentation. So plt.barchart. And as you can see, we have Matplotlib bar chart. And now we see that what we're supposed to do is that we have to put 1, 2, 3, 4, 5, and I guess it's going to be the X here, 1, 2, 3, 4, 5, and then we have data, and this is going to be the count. So for example, for 1, it's 23, for 2, it's 45, for 3, it's 56. Alright, so let's just look at this in practice. Now, let's say I had my labels is equal to apple, orange, and then banana, and then I would have my count is equal to 10, 20, and then 5. Then if I follow the documentation, I have to put the X labels here and then the height of these bars. So plt.bar labels count. Is that it? Yep. Now just run another plt.show, and now I can just say plt.title bar charts, bar chart of fruit. Let's run it. We're going to have more charts. Close this and close this, and we have our beautiful bar chart. So apple at 10, orange at 20, and then banana at 6, I believe. Banana at 5, my bad. But so banana at 5. So this was bar charts, and now we're up till scatter plots. And scatter plots are just, you can just give coordinate of points, and then it's going to scatter all these points and then print and then plot it for you. So I'm going to generate two numbers, so two lists from random normal distribution, and I'm going to plot it. And you'll see that it creates some sort of cluster. So I'm just going to say that x_random is equal to np.random.randn of what? Of, let's say, a sample size equal 1,000 sample size, and copy it, and y_random is the same thing, and now I can just say plt.scatter x_random and then y_random. Can't put a title, so plt.title scatter plot of random normal of 2 random normal variables. Now we just plt.show, and now we can run it. Yeah, we've seen it, and we've seen this, and we've seen this, and now we have a beautiful scatter plot of 2 random normal variables. So just for fun, I want to add more zeros, and we'll see if it works. Because I want to see a cluster. That was a bit sparse. And yeah, this is beautiful. So this is a beautiful cluster from 2 random normal variables. So what's next? Now we have to plot images. Alright, that's fun. So let's say I had a certain image, and it's pretty convenient. We're just going to want to display the plot that we displayed. So Matplotlib has something that allows you to read image, and if I remember correctly, it's plt.imread. So Matplotlib imread, best thing is to read documentation because I trust them much more than me. And then we see that it reads the file name, and that's all. Alright. So plt.imread image.png, and then I can just say data is equal to this, and to show it, it should just be plt.imshow, and then I put data. So let's just put a plt.title, so image of Matplotlib previous plot. Now I can just say plt.show, and now we run it again. So yep. And now we see we have an image of a Matplotlib plot. So this is actually very, very awesome. Finally, we're just going to look at subplots. And what are subplots? Basically, a subplot is that you can put multiple little plots inside the big plot, and then you can see all of them at once. So this is very useful, for example, if you want each plot to be an image, and then you can have a gallery view of all images. So let's just do that right now. So what I'm going to do is that I'm going to define a variable called layout, and it's just going to be a tuple, so a pair or a triple, truple, quadruple, whatever. So just two numbers, so it's going to be 10 by 10 images. And then what I'm going to do is that I'm going to say, so total plot is equal to layout 0 times layout 1. So this is a total number of total plots. Total number of plots. And then for I in range, total plots. Now I can just say plt.subplot. I'm going to explain what it means later on. Layout 0, layout 1, and then I plus 1. And then I can just do plt.imshow. And I just take the previous data from here, plt.imshow data. And now I should say plt.show. And we're going to see what it's going to do. Yep. And now you have to wait a bit. Perfect, trying to drink some water. And as you can see, we have 10 by 10 images of the plots that we wanted. So we're now going to explain what the code actually meant. When I say for I in range total plots, I'm just having a variable I that's going to go 0, 1, 2, 3, 4, 5, 6, 7, 8, 9, up till exclusively total plots. plt.subplot layout 0, layout 1, then I plus 1. It's just going to say that I'm going to do a subplot, and that subplot is the I plus 1 subplot from a layout that has a width of layout 0 and a height of layout 1. So let's just make sure if it's actually width and height. So if I put 2 by 10, I just need to confirm that it's actually going to be a width of 2. So let's just run it. Yep. And it's actually 2 by 10. So I just retract what I've said. It's actually 2 rows. So the first one is going to be the row, and then the second one is going to be the column. So plt.subplot, the number of rows in the subplot, the number of columns in the subplot, then the index of the subplot. And Matplotlib starts counting with 1, which is actually kind of like blasphemy in programming. So this is going to start at 0, but when we put 0, Matplotlib is going to say, what is the 0th plot? It doesn't make sense. So we have to make 0 plus 1, and then it will say, put this image at the first plot. So this works. This is perfect. Finally, I guess as a little souvenir, we can just say plt.savefig plot of plots.png. So let's run it. And now we see this, and this, and this, and this, and this, and our beautiful 2 by 10. So let's just see if it created an image. And now you have plot of plots that looks like this. Now, of course, there was something quite undesirable that I've seen in my subplots, and it was that there was lots of labels. So each image had like from 0 to 250, and I thought that is pretty ugly. So I want to disable the axes. So I can just say plt.axis off. Let's run it. Yep. And now as you can see, each image here does not have an axis. So these are the axes from the image itself. So that's pretty much all about Matplotlib. Thank you so much for watching. If you like this content, like, subscribe, do all that good stuff. And in the next video, we're going to go back at learning Python, and this time we're going to look at decorators. So stay tuned.